Today for our DMA10, we are going to start with Section 8. Section 8 is the order of operations. We have briefly mentioned this before. We're going to mention this again. As we're looking at the order of operations, the first thing that we're always going to focus on is if there is something in parentheses. You want to simplify what would be inside of a parentheses before you get started. If we have a problem that looks like a fraction, so there's a line in between, you would simplify everything that would be in the top, and you would simplify everything that would be in the bottom as if there had been a parenthesis around it before you would then simplify. The next thing in order of operations is going to be the exponents. If you happen to have exponents in the problem, you will simplify those. The next part would be multiplication or division. When you're doing multiplication or division, you work them left to right as you get to them, just as if you're reading in a book. The last is addition or subtraction, and again, we work those from left to right. So what we're going to do, in any of these, the multiplication, division, addition, subtraction, earlier when we did order of operations, it was just all positive numbers. Now, as we do them, we're going to be dealing with positive and negative integers. So those rules of multiplication and division, if it's the same sign, your answer is positive. If it's a different sign, the answer is always negative. We got to keep those rules in mind. For addition and subtraction, remember, we rewrite subtraction as addition, then we follow the rules for addition. If you have the same sign, you add the numbers. Once you add the numbers, you keep the sign they had. If you had different signs, then you find the difference. Once you have found the difference, you then use the sign of the one with a larger absolute value. What we're going to do, and please, if you have your workbook there with you, please take your workbook out as we are going to work with these problems together. We're going to start with some simple ones, and then we'll move into some more complicated ones. Let's start by looking at page 1-46. As you're on page 1-46, we have a series of problems that we can work with order of operations. Let's look at this first one. 3 squared minus 5 minus 4 cubed. Now, if I'm going to do this problem longhand, all right, so within the parenthesis here, we do have an exponent. So before I can do 5 minus, I've got to simplify the 4 cubed. So we're going to use our calculator. 4 raised to the third power is going to give us 64. So this number would be a 64. The 3 squared, 3 times 3 would give us 9. 3 squared gives us 9. Then I'm going to bring down minus, parenthesis, 5 minus, and that was a 64. Okay. So I simplified both exponents. I now need to finish simplifying 5 minus 64. So with 5 minus 64, we're going to get a negative answer. It's going to give us a negative 59. So we have 9 minus a negative 59. Remember, with subtraction, we would rewrite subtraction as addition. We keep the same number, we change to addition, and then we write the opposite. And that would be a positive 59. 9 plus 59, 9 plus 59 is going to give us 68. So 68 would be our final answer. Now, this is working the problem longhand. If we wanted to do this problem using the calculator, what I recommend would be this. We have 3 squared minus parenthesis, 5 minus 4, raise it to the third power. Now notice, the cursor's still up high. I need to make it come back down. That's a blinking arrow. So you touch the right arrow key, now it came back down, and I can close my parenthesis. This is now identical to the written problem, and when you press enter, we get the solution of 68, which is what we came up with. Okay, let's do another. On that same page, let's do problem number 4. Problem number 4, we have, and I'm going to write this about middle of the page. We have a 2 with a negative 7 squared minus 10. Then we have straight lines. If you recall, those straight lines were called the absolute value. So this is where I mentioned we would simplify the whole numerator and the whole denominator separately as if they were their own parentheses. Just as I made note here, that's what I'm referring to. So before I can multiply, I've got a negative 7 to the second power. Do you notice the parentheses is around the negative sign? So that means I would have negative 7 squared. That's going to give me a positive 49. If you typed it this way, the second way is the incorrect way for this particular problem. This one doesn't have a parenthesis and it gives us a negative. So when you type something in, be sure that you type it correctly. So this would be a positive 49. So what I have is 2 times 49 minus 10. I'm going to work left to right. 2 times 49 is going to give us, should be 98. So we now have 98 minus 10, and that combined gives us 88. In the denominator, the absolute value of negative 5. Absolute value is the distance that a number is from 0. It would be 5 places. The answer is always positive. Now we have 5 plus 3, that gives us 8. We have 88 divided by 8. And when you calculate that, 88 divided by 8, that gives you 11. So be careful in case you have something where there is a absolute value symbol that might be blended in there for you. Okay, let's look at another one. Let's look at problem number 5. I just wanted to choose another one that had another absolute value for you. 3 minus 43, absolute value symbol around it, divided by 5. Okay, first we're going to do 3 minus 43. So 3 minus 43 gives us a negative 40. So we have the absolute value of negative 40. That would give us a positive 40. And then 40 divided by 5 gives us a solution of 8. Let's do another one that looks a little more complicated just because it looks like a big fraction here. We have negative 7, and these are parentheses that I'm writing here. Anytime you have numbers in parentheses side by side, that means they're being multiplied. Now this one is not a absolute value, it's what I call a squared bracket, because there's a parenthesis for this problem inside a parenthesis. So the parenthesis is on the innermost, and then the bracket is like the next set of parentheses. So if I were to do this problem, I'm going to simplify the numerator first. Now for this, technically in the numerator, there's not parenthesis per se. This is just you're multiplying two numbers. These are negative numbers. They put them in a parenthesis. A negative 7 times negative 5, negative and negative is a positive 35. Minus, we have 3 times 5, both positive, which would give us 15. Now we've got 35 minus 15, which will give us 20. And let's check that on the calculator. So if I were checking this, I would type in parenthesis -7, and then in the next parenthesis -5 minus 3 times 5. That gives me 20. Okay, so do check through that. So 20 is our numerator. In the denominator, 5 next to this parenthesis means multiplication. But inside of this, I still have another one. I have 5 minus 12. So this is what I'm going to do first. So 5 minus 12 is going to give me a -7. So I now have, and I'm just recopying, this simplified to -7. Now within this bracket is 7 divided by -7. So 7 divided by -7 gives us a -1. And I now have 5 times -1, which gives me a -5. To get your final answer, you're going to do 20 divided by -5, and that's going to give you a -4. So -4 would be your final solution. And one other example here is at the very bottom, number 8. They ask you to evaluate 2x cubed minus y when x equals 3 and y equals 2. That means we're going to substitute these numbers for these letters. So I have a 2, I'm going to have something cubed and then a minus. Let me put those numbers in another color to draw attention to them. The x is the number 3. So where the letter x is, the x is going to be replaced with the 3, and the 3 is going to get cubed. The y is represented with a 2. So where the y would be, I'm going to put the number 2. So this is 2 times 3 cubed. Let's first do 3 raised to the third power. That gives us 27. So we have 2 times 27, we did this first, minus 2. Okay? The next thing we're going to do is this multiplication. So 2 times 27 gives us 54. And then 54 minus 2 would give us 52. So that will be all of what we're looking at in section 8, okay? Our very last section that we have is section 9. Section 9 is geometry. Geometry is a lot of fun. And if you look on page 1-47, I'm not going to recopy and recreate this entire page, but I want you to make reference to it. Page 1-47 in your Leap Log workbook. So turn to that page as I am referencing this. I'm going to make some notations, but I'm not going to draw out and write out everything in detail here. On this page, we're talking about different geometric terms. The first term that we're going to talk about is just simply a point. A point is going to be a dot. It's going to be labeled with a letter, usually capital. If it had a lot of dots, they might do capital and lowercase. But it is a point that's represented by a dot on this image that we're going to be having. The next thing that we're going to mention is something that's called a line. A line is a set of points that extends in opposite directions. I draw the arrows on the end to show that it extends in both directions. And then I have letters to label what that line is. If I want to abbreviate this, I would have written a little line with an AB. That's how I would write the abbreviation for that. The next term that we see is a line segment. A line segment has endpoints. Since it has endpoints, it does not go on forever and ever. It stops at both of these points. The abbreviation for that would be simply a straight line with an AB up underneath. Let me also mention here, if you have one endpoint and then let's say it continues off in a direction, we would call this array. Array has one endpoint and then it continues in the other direction. When you label array, you put the endpoint first and then the other value would come after that. Two rays put together form an angle. An angle is formed by two rays. There would be an endpoint. Let's say here we might name this C, this is B, and this is A. When we have an angle, we measure it in degrees. So the measurement from here to here would be in degrees. The way that we would write this angle would be either angle CBA or angle ABC, or we could call it simply angle B. B is the vertex. So this point B, let me make note with another color here. B is what we call the vertex of the angle. The vertex is where the two endpoints meet. The last item on this page that I need to mention, and my drawings are not always perfect, but this is a plane. We're calling this plane A. It's a flat surface with no thickness that extends in all directions. It is a flat surface that extends in all directions. That would be your plane. Now, the next thing that we're going to look at with angles in particular, there are different types of angles, special kinds of angles. So we are going to classify angles. I'm going to label four different types of angles up here. So I'm going to draw them first, and then we're going to talk about each one. Now, the name of this first angle here, this would be like my vertex. The measurement of the degrees is 180 degrees. 180 degrees is represented by what we call a straight angle. It looks like a straight line. A straight angle actually is a straight line, and it specifically has a measurement of 180 degrees. The second angle here, this is called an obtuse angle. The measurement of an obtuse angle is between, right here, degree is between 90 and 180. It's not going to be 180 because that's a straight angle. It's not going to be 90 because we're getting ready to talk about 90, which is a 90-degree right angle. The measurement is between 90 and 180. So 90 point anything up to 179.9. This angle, if you ever see a little square drawn in a corner, it represents exactly 90 degrees. 90 degrees is a right angle. Think about in our earlier section, we talked about a Pythagorean theorem, and we can only use that Pythagorean theorem when we're dealing with a right triangle, meaning if the triangle had a 90-degree angle. So this is a special angle, and the measurement is exactly 90 degrees. The last angle here that I'm going to name is, this is an acute angle. The measurement for an acute angle is going to be, the degrees will be between 0 and 90 degrees. Okay? Can't be 90, it'll be like 89.9999. But between 0 and 90 is going to be an acute angle. As we look at different types of angles, we have two very special terms called complementary and supplementary angles. Complementary angles have a sum of 90 degrees. Supplementary angles have a sum of 180 degrees. The way that I remember the difference in the two, supplementary starts with the letter S, straight angle starts with the letter S. If a straight angle is 180 degrees, supplementary angles, when we combine the sum of those, it's 180 degrees. So that's what helps me remember which is which. So, for example, at the bottom of the page, it says, find the complement of a 14-degree angle. So if I have an angle and I tell you this measurement here is 14 degrees, I want to know, what is this measurement? The way I'm going to find the complement is I'm going to take 90, I'm going to subtract 14, 90 minus 14 is going to give me 76. So the measurement here is going to be 76 degrees. Because when you have a right angle, the sum is 90. The complementary angles have a sum of 90. So if they give you one measurement, you can subtract it from the 90 and find that missing amount for that angle. This one is asking me to find the supplement of an 83-degree angle. Okay, supplementary have 180 degrees. So let me mark this. If this side is 83 degrees, what is the measurement of the other side? To find this measurement, I'm going to take 180. I'm going to subtract 83. 180 minus 83 is going to give me 97. So the supplement of a 83-degree angle would be 97 degrees. Now, how do we go about finding measurements of angles that we are given? If you look in your book, go over to page 1-50. I'm going to draw a straight line here, and I'm going to label it just as they have. We've got a 45 degree. We got a 39 degree. We've got a 24 degree. And we've got one that's just labeled B. Okay? If I'm trying to find the measurement of B, if I want to know this measurement, we know a straight line is 180 degrees. When it's straight, it's 180. If I need to know what B is, all of these angles are adjacent angles. That means they're all attached to each other. If we know this whole measurement is 180 and they're all touching and attached, the sum of all of these should be 180 in this scenario. So I'm going to add 45, 39, and 24. So we're going to add 45 plus 39 plus 24. That gives us 108. If I know it's a straight line, I'm going to subtract 108 from 180, and that's going to tell me that angle B is 72 degrees. So I can find that measurement by knowing that. Let me give you another example. Let's say we have a right angle, and I know it's a right angle because it's labeled with that little square in the corner. If I draw a line through here, and let's say this distance from here to here is 50 degrees, how can I calculate the measurement for angle C? Angle C here, I know the box means it's 90 degrees. If I subtract the 50 that we already know, that would give me 40 degrees. And isn't 40 plus 50, 90? Another term that we need to know will be the term vertical angles. Vertical angles are opposite intersecting lines. And also they are equal. So if I have two lines that are intersecting, and if I were to label this measurement here as 60 degrees, if this measure is 60, the vertical angle to it is on this side, it is also 60 degrees. When we mentioned adjacent angles, they're angles that are side by side that make that straight line. If this is a straight line and this much is 60, if I took 180 and I subtracted 60, that would give me 120. That would mean this angle is equal to 120. These two are vertical from each other, so this line here is also 120. We still have more language, more vocabulary. If you turn over to page 1-51, you're going to see some more additional language that we need to know. Parallel lines. Parallel lines are in the same plane and they never intersect. So if you have two lines that are drawn equal distance apart that never intersect, I might label this one A and this one B. A is parallel to B. That would be the symbol for the parallel lines. So parallel lines will say they never touch. They never intersect. Never touch nor intersect. Perpendicular lines are special. They intersect at 90-degree angle. This would be like a perfect crossroad, an intersection. Those lines would be perpendicular. You would say line A is perpendicular to line B. It looks like an upside down T to represent perpendicular. Two lines that merely cross are intersecting lines. There is a word called a transversal a transversal line crosses in this case, we're going to have two parallel lines. So if these are my parallel lines, my transversal is going to be this. The transversal is the one that crosses the two parallel lines. We are also going to talk about two other terms. Let me finish labeling this. Two terms that are alternate interior and corresponding angles. Okay. Alternate interior angles are on opposite sides of the transversal and inside the parallel line. So alternate interior angles would be angle 3 and angle 6. They're both on the inside of the parallel lines and they're on alternate sides. So angle 3 and angle 6. Also angle 5 and angle 4 would be considered alternate interior. If I wanted to identify, let's see, corresponding angles, corresponding angles are in the same relative location. So, for example, if I were to start with angle 1 being here, what is in the same relative location as angle 1? Being above the parallel and to the left of the transversal. What would be corresponding to 1 would be angle 5. If I were to look at angle 2, angle 2 is a corresponding angle 4. 2 is here. It's on the right of the transversal. It's above. It's in the same location as the 6. If I were to look at, let's say, angle 3, it's in the same corresponding location as, now 3, if you'll notice, is below the parallel line and it's inside. So 7 would also be the one that would be in the same corresponding location. If I looked at angle 4 is in the same corresponding location as angle 8. They're both below the parallel line and to the right of the transversal. So let me give you a scenario here where we have two parallel lines, and this is what you'll see on page 1-52. Go to page 1-52. You have parallel lines with a transversal, and they label the chart, and they're going to actually give you a physical chart to fill in. They give you the angle, and they ask you for the measurement. So they simply give it to you as a chart to fill in. They do it in 2 columns. I'm writing it in 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, they give us one measurement and they tell us that angle 2 is 45 degrees. they tell us angle 2 is 45 degrees. So I'm going to label angle 2 as being 45. And actually, let me do these in another color. They give me angle 2 is 45. Okay? I'll put that in red. That's the one they give us. So if I know angle 2 is 45, I can identify which other angles are 45 degrees. 2 and 3 are vertical from each other. Vertical lines are the same measurement. So if 2 is 45, 3 is also 45. Now, angle 2 and angle 6 are in the same corresponding location. So that means angle 6 is also 45 degrees. Angle 6 to angle 7, 7 is also in the same corresponding location as angle 3. So angle 7 is also 45 degrees. Let's say I want to calculate what the measurement of angle 1 is. This is a straight line. A straight line is 180. So if I do 180 minus 45, I would find the supplementary angle of that. So let's do 180 minus the 45. So angle 1 is 135 degrees. So if angle 1 is 135, the corresponding angle is number 5. Number 5 is also 135. Angles 1 and 4 are vertical from each other, so that means 4 is also 135. And 4 and 8 are in the same corresponding location, so that would also be 135 degrees. So that's as complicated as it'll get when it's asking you for identifying angle measurements. But if they give you one measurement, you can calculate the rest. With geometry, we're also going to look at some other terms. Let's look at the word perimeter. Perimeter is like putting a fence around something. A fence around. You will add all exterior sides to find the perimeter of something. So if I give you this rectangle and I label these sides, you can find the perimeter. The perimeter is going to be 2 plus 10 plus 2 plus 10. You're going to add all of those together. 2 and 10 is 12, 13, 14, 14 and 10 is 24. So the answer would be 24 units when you're finding the perimeter. For area, you're going to multiply length times width. So if you have, and even if it's a square, you label 2 of the sides. If one side is 8, you label the other side 8, and the area is going to be 8 times 8, which would give us 64. When we deal with our units are always going to be squared when we deal with area. If we have one that has 2 different lengths, let's say this one is 2 and this one is 7, our area here would be 2 times 7, which would give us 14 square units. When we do the area of a triangle, the formula is 1/2 times base times height. So whatever your triangle may be, the bottom down here is the base. The height is going to be labeled, you're going to figure out what makes a 90-degree angle. This line here is going to be in red, is going to be the height. Another way you might want to write the formula is base times height divided by 2. That would be an easy way to label it. So if I tell you that the bottom is 10 and I tell you that the height is 4, my area would be 10 times 4 over 2. 10 times 4 is 40. 40 divided by 2 would be 20. And our units, again, are going to be square units.